Welcome to EDU World Space.
Okay, in this problem, we'll be talking about how to find the unit tangent vector, the unit normal vector, and the curvature of a given vector in space. So we're starting with this vector here, and we just want to go through each of these and show how they're sort of interrelated. There's just a lot of formula to memorize, really. Okay, so we'll start off with finding the unit tangent vector. In order to do that, notice we'll need to find the derivative of this vector. So we'll start by finding the derivative, neaten that up a little bit. We'll find the derivative, r prime of t, this vector. Derivative of t is 1. Derivative of 3 cosine of t is negative 3 sine t. And derivative of 3 sine t is 3 cosine t. And then we want to find the magnitude of this derivative. So remember, to do that, you just take the square root of the sum of the squares of each component. So we have 1 squared plus negative 3 sine t squared plus 3 cosine t squared. And we'll just simplify this. 1 plus 9. We're going to have 9 sine squared t and 9 cosine squared t. So I'm just going to factor that out. And that's nice because this is a Pythagorean identity. Sine squared t plus cosine squared t is 1. So this simplifies to 1 plus 9 times 1, or 1 plus 9. And that's just the square root of 10. So now getting back to the question at hand, we want to find this unit tangent vector. It's just going to be the derivative of the given vector divided by the magnitude. So each component is divided by the magnitude. All right, and that's our unit tangent vector. That was the first part it's looking for. Now we want to find the unit normal vector. And the unit normal vector is doing the same thing that we just did, except instead of starting with the original vector, now we'll start with the unit tangent vector. So we need to start by taking the derivative of the unit tangent vector. The derivative of 1 over root 10 is 0. It's a constant. Okay, derivative of negative 3 over root 10 sine t is negative 3 over root 10 cosine t. And derivative of 3 over root 10 cosine t is negative 3 over root 10 sine t. So there's our derivative of the tangent vector, and now we need to find its magnitude. So again, we'll just square the components and add them together and take the square root. So 0 squared is 0. I'm not going to bother writing that. We'll square 3, negative 3 over root 10. If we square that, we'll get 9 over 10 cosine squared t plus 9 over 10 sine squared t. Just like before, we can factor out a 9 over 10 and use the Pythagorean identity. And that leaves us with 9 over 10 times 1, which is just 3 over root 10. And now to find the unit normal vector, we go ahead and divide each component of the derivative of the tangent vector by the magnitude of the derivative. So 0 divided by 3 root 10 is 0. Negative 3 root 10 divided by 3 root 10 is negative 1. And we're left with cosine t. And negative 3 root 10 divided by 3, negative 3 over root 10 divided by 3 over root 10 is negative 1. So we're left with negative sine of t. So there's our unit normal vector. And then finally, to find the curvature, we've done the hard work. It's just kappa t. We just take the magnitude of the derivative of the unit tangent vector, the magnitude of the derivative of the original vector, divide those, that'll give us our curvature. So we found that already. The magnitude of this guy was 3 over root 10. And the magnitude of our original was root 10. So dividing by root 10. This is just equal to 3 over root 10 times root 10, 10. There's our curvature. So we found our unit normal, our unit tangent, and our curvature of this given original vector. Thank you for watching. I hope this was helpful.